Hey guys, it's Vincent, and in this video I'm going to go over how to solve a two-dimensional projectile problem. So the problem is, a cannon at the top of a cliff shoots a cannonball 70 meters per second at 30 degrees above the horizontal. If the cannonball reaches the ground below the cliff 900 meters away, what is the height of the cliff? There is no wind, so neglect air resistance. So this is a diagram to help you visualize the problem. As you can see, we have the cannon over here shooting the cannonball at 70 meters per second at 30 degrees above the horizontal. And down here you can see that the cannonball travels 900 meters in the x direction. And we have a question mark here because we're trying to find the height of the cliff. So what do we know so far? In the x direction, we know that the cannonball travels 900 meters because that's where it lands. And since the problem states that there is no air resistance, we can assume that the acceleration will be 0 meters per second squared. If this is true, then the final velocity has to be equal to the initial velocity because nothing is slowing the cannonball down. In the y direction, the acceleration is negative 9.8 meters per second squared because of gravity. To find the initial velocity in the x and y direction, we must resolve or split the vector into its components. These are the trig functions that may be useful for resolving vectors. So we know that theta, or the angle, is 30 degrees, and the hypotenuse of the vector triangle is 70 meters per second. We're going to use the trig function with cosine to solve for the x component because the x component is adjacent to the angle. So substituting 30 for theta and 70 meters per second for hypotenuse, we get cosine 30 equals the x component over 70 meters per second. We can solve for x component by multiplying both sides by 70, which gives us x component equals 70 times cosine 30, which ends up being 60.62 meters per second. We're going to use the trig function with sine to find the y component because the y component is opposite of the angle. So once again, substituting 30 for theta and 70 for the hypotenuse, we get sine 30 equals the y component over 70 meters per second, and solving for the y component, we get 70 times sine 30, which ends up being 35 meters per second. So looking back at the table of things we know, we can fill in that the initial velocity in the x direction is 60.62 meters per second. And since the final velocity is equal to the initial velocity, we can also say that the final velocity is going to be 60.62 meters per second in the x direction. In the y direction, we can fill in that the initial velocity will be 35 meters per second. And that's all we know so far. We can't find the height of the cliff yet because we don't have enough information in the y direction, such as the time. But the time in the y and the x direction is the same, so we can use the information we know in the x direction to find the time. Looking at the information we have in the x direction, we can use the displacement formula because we know the displacement, we know the initial velocity, and we know the acceleration. But we can simplify this formula because we know that acceleration is equal to 0 in the x direction. 1/2 at squared is also going to be equal to 0. So it ends up being vit plus 0, or just vit. So we can rearrange these displacement formula to solve for t, which ends up being t equals, or the time, equals the displacement over the initial velocity. So substituting in the values for the displacement and the initial velocity, we get time equals 900 meters over 560.62 meters per second. And doing some unit analysis, we can eliminate the meters. They cancel out, which leaves seconds, or 14.85 seconds. So now we have enough information to find the displacement in the y direction. So we can once again use the displacement formula, because we know the initial velocity in the y direction, we know the time now, and we also know the acceleration, which, well, the initial velocity is 35 meters per second, the acceleration is negative 9.8 meters per second squared, and the time in the air is 14.85 seconds. Substituting the values in, we get 35 meters per second times 14.85 seconds plus 1/2 times negative 9.8 meters per second squared times 14.85 seconds times 14.85 seconds. Doing some unit analysis, we can eliminate some units, and we end up with only meters. So it ends up being negative 560.81 meters, which is how far down the cannonball dropped in the y direction. Since it fell 560.81 meters, we can say that the height of the cliff was also 560.81 meters, which ends up being the solution. I hope you guys found this helpful, and thanks for watching.